Hi, I'm Mrs.D. Math. Thanks for joining me today. We're going to cover linear relationships and bivariate data in 8th grade math. Bivariate data is data made up by two paired variables. These are your independent variable x and your dependent variable y. We can determine if these variables have a linear or nonlinear relationship. We've already been covering bivariate data, we just haven't brought up the word yet, but bivariate data is made up of two paired variables. There's also univariate data, which would be one variable. So that prefix bi means that we have two. And in our case, we have x and y. We have been using those on tables and graphs. So let's go ahead and take a look at the graph here that we already have made. And this is a linear relationship. You can tell because it does form a straight line from the points that we are given. It is non-proportional. It does not go through the origin. But we do see here that our bivariate data has an x and a y, and they are labeled with distance and cost. Because it is a linear relationship, we can find our slope, and we can also fill out our y equals mx plus b slope-intercept form. So let's go ahead and find a couple of points here on the graph so that we can use those in our formula. So here for this point, we are at 411. And for this point down here, we are at 2, 7. And I did have this labeled y2 minus y1, x2 minus x1. They are interchangeable. It doesn't matter which one we start with. You just have to remember that if you use the 11 for your first y, you have to use the 4 for your first x. So do keep the ordered pairs together on the top and the bottom above each other. So let's go ahead and plug in our y, 11 minus 7. And since I did 11 for my first y, I'm going to have to do 4 for my first x. So 4 minus 2. So when I solve that, 11 minus 7 is 4, and 4 minus 2 is 2, and I know that equals 2. If I were to use my graph over here and just count from point to point, I would go starting at 2, 7. I can count up 4, so that's my rise, over my run, which is over 2. So again, 4 over 2 is going to reduce to 2. So let's go ahead and start filling this in. We have y equals 2x, that's my slope, plus, and I can find that y-intercept right here on my graph. I'm going to go from 0 up to 3, so that would be plus 3. The other thing I could do is go back to my formula here and plug in one of my ordered pairs for y and x and solve for b. However, when it's easy to see on the graph, it's much easier just to plug in a 3 because we know that's where it crosses the y. So one thing we can do with bivariate data, if it's a linear relationship, is make a prediction. And we can use our formula, y equals 2x plus 3, or we can use the graph. So let's say I want to predict the cost for 4.5 miles. I know that 2 miles is $7. I know that 4 miles is $11. I want to figure out what 4.5 miles would cost. So let's use our formula here. We have y, which in this case would be what we're looking for, equals 2 times 4.5 plus 3. And I know that 4.5 goes with the x because it is labeled miles, and miles is my x on the graph. So now I can just solve. Y equals 4.5 times 2 is 9, and I know 9 plus 3 is 12. So I can predict at 4.5 miles the cost would be $12. I can also go over here to my graph, and if I go over to the 4.5, that's going to be right in between the 4 and the 5 on the x, and go up to where the line crosses that point. I can see that right here. And then from this point, I can just go straight across to my y, and at that place, I am at 12. So I do know from the graph and from my equation that at 4.5 miles, the cost is going to be $12. So let's discuss bivariate data a little bit more. And here I have two graphs. And I know that from graphs, this is my x, this is my y. So there's my two things that I'm comparing. both of them have an X and a Y. So both of them have data that's been compared by two different things. I can try on the left side, the left graph, to go ahead and connect my points. When I connect my points on the left graph, I can see that it does form a straight line. So this one on the left is linear. And then on the right side, if I go ahead and connect a couple of points, it's pretty easy to see that this graph is non-linear. It does not follow a straight line. If I connect two of these points and continue, the other points are not on that line. So this one is non-linear. And if you notice the difference in the graph on the right and the graph on the left. So I can see here on the left graph, it does have a consistent slope. I can go up 2 over 3. So my rise over run is 2 over 3. If I continue to go up 2 over 3, I'm still at a point on the line. But if I do that over here, my first one here, I go up 2 over 2. And then if I go up 2 over 2, that point is not on my line. And then if I went up 2 over 2 again, this point is not on the line. So this one is non-linear. It is increasing at a different speed. It does not have a consistent slope. So anytime you have two paired variables, in this case X and Y, we can use that bivariate data and we can plot our points on the graph and then determine whether it is linear, like the one on the left, or nonlinear, like the graph on the right. Thanks for joining me today for linear relationships and bivariate data in 8th grade math. I'm Mrs.D. Math. Have a great day. Bye.